Hello everyone. Linear programming is a powerful tool used to maximize the profit and to minimize the cost under various constraints by which the business is bounded. In order to understand this concept, here we discuss a very simple problem. Ravi borrows a motorbike for a joyride on the conditions that it will be returned within 1 hour and he would pay for petrol from his pocket. He has only rupees 200 to spend. If he drives it at a speed of 25 km per hour, he has to spend rupees 4 per kilometer on petrol, and if he drives it at a speed of 40 km per hour, the petrol cost increases to rupees 10 per kilometer. What is the maximum distance he can ride within his limited resources? As we can see, Ravi is here with two constraints. One is time constraint, one is money constraint. Still, he wishes to maximize the distance that he can cover. Also, he is there with certain data. If he chooses the speed 25 km per hour, his expenditure will be 4 rupees per kilometer, and if he chooses to choose the speed 40 km per hour, the cost will be 10 rupees per kilometer. Let's take a case. If he chooses 40 km per hour in 1 hour, he will ride 40 kilometers for that. He will have to spend 40 into 10, 400 rupees which he doesn't have. But if he chooses the other speed, in 1 hour, he will cover 25 kilometers. It will cost him only 25 into 400 rupees. He is left with another 100 rupees. But the time is over. He feels bad. Now let's see, how can linear programming help him out here? As he doesn't have any more data with him, he prefers to choose either of these speed only in his ride. Suppose Ravi is ready for his ride. We are going to suggest him to ride for X minutes at the lower speed, that is 25 km per hour, and for Y minutes at the faster speed 40 km per hour. X and Y both being time have to be more than or equal to 0, cannot be negative. Here, two segments of rides. In first segment X minutes, second segment Y minutes. The total time he would take is X plus Y minutes, which cannot be more than 60. He has to return it in 1 hour. So, we can write this condition as an inequation X plus Y less than or equal to 60. This is the first constraint that he has to maintain. Also, in these two segments, the speed he chose are 25 km per hour and 40 km per hour respectively, which means 25 by 60, that is 5 by 12 km per minute, and 40 by 60 and equal to 2 by 3 km per minute. And the distance he would be able to cover in the first segment will be distance is equal to speed into time, that is equal to 5 by 12 into X kilometers in the first segment, and in the second segment 2 by 3 into Y kilometers is the distance that he can cover. So the total distance he will be able to cover will be 5 by 12x plus 2 by 3y. 5x by 12 plus 2y by 3 is the total distance that he can cover. Also, the cost for the first segment per kilometer, it is 4 rupees, and he will be covering 5x by 12 kilometers. Hence, 4 into 5x by 12 rupees will be the cost for the first segment, and for the second segment it will be 2 by 3y into 10 will be the total cost for the second segment. Altogether, the total cost will be therefore 4 into 5 by 12x plus 5 into 10 into 2 by 3y, which cannot be more than 200 rupees. Hence, we get another inequation, which cannot be more than 200 rupees, which is simplified into x plus 4y less than or equal to 120. This is the second constraint that he has to keep in mind. Also, x greater than or equal to 0 and y greater than or equal to 0 also are two constraints to be followed by the variables which we have assumed. Now, our task is to find the best values of x and y So that Ravi writes the maximum distance subject to the constraints on time and cost of ride. These are the constraints. For that, first, using graphs of the inequations, we will find all possible values of x and y which satisfy the constraints. Here, we get a graph. To draw the graph of the first constraint, the first inequation, take the corresponding equation x plus y equal to 60. When x is equal to 0, y is equal to 60. When x is 0, y is equal to 60. So 0, 60 is a point already plotted. Also, when y is equal to 0, y is equal to 0, put y equal to 0, you get x is equal to 60. So 60, 0 is another point to be plotted. Since x plus y equal to 60 is a linear equation, the graph will be a straight line passing through these 2 points. This is the graph of the equation, but we need the graph of the inequation, which is one of the sides of this equation, this line. Which side to be tested? We can take any point and test. I prefer to test using the origin 0, 0. Take x plus y less than or equal to 60, which is the inequation, at 0, 0. Put x equal to 0, y equal to 0 in the inequation, which turns out to be a true statement. Since it is true statement, 0, 0 satisfies this inequation. Hence, all the points on this side will satisfy the inequation. On the other side, x plus y will be greater than 0. So, x plus y is less than 0 on the lower side of the line, which is now shaded. Now we go for the second inequation, corresponding equation here. When x is equal to 0, for y equal to 120, hence y is equal to 30. So 0, 30 to be plotted. Next, when y is equal to 0, when y is 0, x is equal to 120. So we have 120, 0, 120, 0 plotted. So the graph is the line passing through the 2 new points. Again testing by the origin in the inequation. Testing going on. 0, 0 put in the inequation. 0 plus 0 less than or equal to 120 is a true statement. Hence origin satisfies the inequation. So all the points on the origin side of the line will satisfy the inequation. Shade it. Now, x greater than or equal to 0 and y greater than or equal to 0 means it is the first quadrant. In the first quadrant, the 2 inequations are also satisfied. Hence, the feasible region is the common shaded region in the first quadrant. This is the feasible region. This region, all the x and y will satisfy all 4 inequations. Now, remember, we need to maximize the distance that he can cover. For that, we take the help of fundamental theorem on linear programming, which states that maxima and minima of a linear function over a common convex polygonal region occur at the corners of the polygon. Maxima and minima of a linear function. This is the linear function. Maxima and minima of a linear function over a convex polygonal region. This is the convex polygonal region. Occur at the corners. Corners are origin, A, B and C. We need to get their coordinates. 0, 0 is ready. A is 60, 0. C is 0, 30. And we need to get the corner point B coordinates, which is the point of intersection of the lines represented by x plus y equal to 60 and x plus 4y equal to 120. To get the point of intersection, we need to solve those 2 equations simultaneously. Subtracting these 2 equations, we have 3y equal to 60, therefore y is equal to 20. Once y is 20, x is equal to 40, therefore the point B is 40, 20. Now, we need to calculate the value of D at these corner points. The corner points are 0, 0, 60, 0, 40, 20 and 0, 30. Calculate the distances. Distance at 0, 0, 5 into 0 by 12 plus 2 into 0 by 3. X is 0, y is 0. Giving the value 0 plus 0 equal to 0 kilometer. 60,0 put in the D gives you 5 into 60 by 12 plus 2 into 0 by 3 is equal to 25 plus 0, that is 25 kilometer. At 40,20, the distance is 5 into 40 by 12 plus 2 into 20 by 3, which is equal to 50 by 3 plus 40 by 3, that is 90 by 3, that is 30 kilometer. Now 0,30 gives the total distance covered is only 20 kilometers. Comparing these distances at these vertices, we notice that 30 kilometer is the maximum which he can ride. Maximum distance we can ride is 30 kilometers, which he will be able to do by choosing X as 40 and Y as 20. Which means by riding for 40 minutes at the speed of 25 km per hour and for 20 minutes at 40 km per hour. This is what we can suggest him. Do this way. 40 minutes he rides at 25 km per hour, 20 minutes he rides at 40 km per hour to obtain the maximum distance, that is 30 kilometers. This is how linear programming is used in deciding the strategy of a business to maximize the profit and to minimize the cost under various constraints. Thank you.